Right, welcome back after lunch. As I said, I'm going to talk about Puppet module reusability, but a little bit about me. I'm Gareth R. nearly everywhere on the internet. I'm not normally this well-dressed. I do work for the UK government, so I'm all the way over from London. I'm a civil servant. I'm a government employee, but don't hold that against me. A couple of things I've been involved in with sort of Vagrant Boxes and DevOps Weekly, if you've seen that. The last code I wrote was some Lua. But when it comes to Puppet, I spend a lot of time writing both Puppet code at work, but also modules for open source sharing. So I'm actually the 7th top contributor on the Forge. And so I'm going to draw. Ooh, thank you. I guess what this talk has really come about from is basically my experience of shipping a load of modules to the Forge and contributing back to other people's modules I've reused. The last Puppet module I wrote was for Elixir. I've done a bunch of sort of quite low-level like language ones designed for other people to reuse in higher-level modules, and that's sort of part of the talk. So I think there is a problem. I think it's not necessarily the problem, but I think there is a problem with sharing modules. People don't share as much stuff as they should do. I think there's a bunch of reasons why. I think one of them is literally just not invented here. I think this has been really common, like in programming everywhere forever. It's got better a bit, but I think infrastructure as code is sort of bringing a lot of people to programming for the first time, and we're back in a world of not invented here. The Puppet Labs Apache module, there is a module for Apache. If you do a search for Puppet Apache, you probably can't quite see here, but there's 145 results if you do puppet-apache in GitHub. There's probably more that aren't called that. There's probably some not on GitHub, but 145. 145. Like, at least that number of times someone has rewritten the same thing. Even taking the Puppet Labs Apache module itself, it's a pretty good module. There's a lot of stuff in there. There's been 67 contributors from inside and outside Puppet Labs. That's great. But there's 281 forks. What? People are not reusing at this point. Part of this, I think, is that problem of monolithic repositories, vendoring everything, basically taking other people's code, even if you are reusing it, and just copying it into your repository, and then not getting any of the upstream changes, not managing that. I think actually not publishing to the Forge is an anti-pattern. I think the dependency management stuff, the sort of just having one place for module discovery, I think, right, I pulled some numbers from GitHub, and I pulled some numbers from different places, and that's bad. But things on the Forge make that a lot more visible. I think the Forge can do a better job to make those things more visible and shame us into actually contributing back to other people's modules rather than starting a new version. People don't write documentation. Puppet Labs wrote guides on how to write documentation. There's a template. It's great. Modules with too opinionated configuration. I think I sort of describe this as sometimes I just want to write Nginx configuration. I quite like Nginx configuration. It's also insanely big and complicated. I really don't want someone to wrap that in a Puppet type for everything. I don't want to be writing my Lua code that gets embedded in my Nginx config into my Puppet code. That's insane. You can say Lua in Nginx is insane, but that's a different conversation. Duplicate resources as well, where one thing that stops lots of people sharing modules is where they've done something like that. So this module required something to be compiled, and I've included this package. But I have that somewhere else, and I have that in another module that's shared by someone else, and now I can't use all these things, and duplication of concepts between modules stops them being shareable, at which point a lot of people's reaction is, OK, I'll just build my own, and it perpetuates the problem. I think that's the problem. That's the sort of space. And what I want to talk about is sort of some of the things actually that are available now that can help us not do that. and then I'll rant at Puppet Labs about some things they can do inside Puppet. So who's using standard lib, the standard library from Puppet Labs? I'm going to say that's less than half. It's great. There's a load of stuff in this. Basically, it's a Puppet module shipped separate from Puppet with a bunch of useful things in it that I think make writing reusable modules in particular a lot easier. Some of this is basically that you want your modules, if it's going to fail quickly. You want it to fail at compile time. You want to provide validation. We're writing programs that take inputs, and we want them to fail with useful error messages. We don't want, and sometimes that error is going to be in Puppet. Sometimes that error can be handled in your module. Not enough people put error handling into their module to give you useful input. So whether it's simply just failing because the operating system is not supported, you've got some conditional logic, you've wrapped something, you know that's never going to work. I'm using Build Essentials, the package resource that's Debian and Ubuntu. That's never going to work on Red Hat. Like, saying you don't have this package available is nowhere near as good as saying this module doesn't support this operating system. Standard lib ships with a lot of validate underscore functions that make this really easy to do. So you can validate string. You can say, well, version should be a string. Version should be a number, but numbers don't exist in Puppet yet. And so you can get useful errors out of the code. So if I pass true, I've passed a Boolean to version, it's going to tell me true is not a string. It's not going to just go, doesn't work. And that's not going to get all the way through to sort of trying to do, say, install this package where version is true. That doesn't. And we can validate the length of strings. We can validate against regular expressions. We can validate things that hashes. We can validate things based on the execution of an external command. Checking that the pseudo configuration is valid, for example. And we can validate things that are Booleans. We can validate a load of things just by simply saying, I want this to be a Boolean. I want this to be a string that matches this regular expression. And those modules will fail quickly. Standard lib comes with a bunch of things to avoid one of the problems I described about duplicate resources. So back to this sort of problem. Well, one way of solving that is actually, if your module is needing a compiler, it installing it might not be the best thing to do. It relying on a module that installs that is probably a better thing to do. But sometimes, you don't want one module per package when it's just packages. So sometimes you might have some packages that you need as part of your module. Maybe it's Graphite and you need Python LDAP and you need Python pip. But if you define these packages in your module, I can't have any other module that describes them. And if I want to steal modules from 3 or 4 different people, the chances of that happening are just approaching 100%. Standard lib ships with ensure packages and actually ensure resource. And ensure packages is going to do what you think it's going to do. It's going to ensure they're installed. But it's going to do that in such a way that if they're already managed, that's great. If they're not already managed, this will manage them for you. Ensure resource is the sort of the daddy of that in terms of, well, maybe you're not looking to manage packages. Maybe you're looking to manage your user, or maybe you're looking to manage any other resource in your catalog. Ensure resource basically provides a lot more options for doing that. Standard lib ships with things to make nicer interfaces as well. So one reason people give up on sort of like a module that exists and obviously works for someone is that maybe there's some documentation, but actually how to use it isn't clear. Or it just has a really ugly interface. It has an ugly way of getting the data in. So there's a bunch of helper functions, things like string to bool. So basically taking a string, allowing someone to pass in a string or a Boolean and converting it. So basically if it's true or if it's 1, they'll all work. My favorite is any to array. So there's loads of cases where you want to pass a parameter that might be 1 or more values. And then you want to treat that as an array elsewhere in your code rather than having to do a load of checking. You can passing a string to any to array, or passing an array to any to array, both results in an array that you can then treat as an array elsewhere. And there's way more in standard lib. Start using it, have a flick through. It provides a lot of the primitives to make good modules. So dependency management is everywhere else. If you're doing code, if you're writing sort of programming stuff, you're using tools like these, whether it's Bundler for Ruby or Pip for Python or Line Enclosure. Everyone's got these dependency management tools. They all look actually quite similar. And it turns out there are tools like this for Puppet. So librarian Puppet, R10K as well. There's a bunch of other ones that Chad talked about. But fundamentally, like having a big modules directory in your repository with a load of stuff in it is an anti-pattern. Don't do it. Instead, use something like librarian Puppet, like R10K, like any of the tools that are doing this, that allow you to specify dependencies that then allow you to install them. So for a librarian Puppet file, you take a text file, normally called Puppet file, you put this type of thing in it where you're saying, well, these are the modules I want. I want the Puppet Labs Ruby module. I want the Puppet Labs NTP module. You can specify the version. You can specify that they come from a Git repository. You can specify the Git hash from that repository. And you install them via a command line tool. And that's going to put them onto disk. But now then, we've excluded them from our source repository. And we've got a recreatable way of pulling down a specific set of versioned modules. That means if we want to update those, if we want to know there are new versions, so librarian Puppet ships with an outdated command that will tell you which of the modules that you have new versions upstream. You're now not having to do that yourself and remember to do that yourself manually for what starts out as 5 modules and then becomes 10 and then becomes 100. You're not going to do it. So one thing that I think stops people sharing modules as well is just modules look different. I think that's partly because Puppet is not opinionated about how you make your modules. I think as a community, we need to get better at sharing our opinions and agreeing on like best practice, agreeing on community consensus for structuring modules for reuse. There's a bunch of writing about this, and there's a bunch of things around sort of roles and profile type things at a higher level about managing like your entire infrastructure. What I'm interested here in is basically an individual module. So Ari wrote this sort of basically module sort of pattern stuff, and a lot of comments came out of that. And a lot of this is around having classes for install, config, service, and params. So extracting these sort of common things out for all your modules to use. So rather than having just sort of your manifest file and having it, you've just got an init file, everything's in there. Or you've got a collection of different things for different circumstances. You nearly always start out with that as a default. And sometimes maybe what you're managing doesn't have a service. Well, then delete it. I think that's better than, like, starting out with an opinionated set and deleting some of it is in my view, better than the other approach of sort of building it up from scratch. If I come to a module and it's got that, I know where things are going to be. And as well as knowing where things are, I know what the relationships between things are as well. So you can end up with quite spaghetti Puppet code quite easily if everything's in one module or if it's in one class or multiple classes, where you're using lots of require and you're using lots of notifying. You're building up lots of relationships that are specific to how you've written that module. But actually, if we've got agreed upon ordering between sort of our install and our config and our service classes, then again, I can just look at a class. There's no notifies, there's no requires in there, but I know that in the other class, that's going to basically happen first. The ordering is going to be right. If it changes, it's going to notify. Unfortunately, nothing's quite as simple. That was sort of the stuff that Ari talked about. That works actually most of the time, except where you start doing requires of the classes outside, and you end up having to get into the world of anchors, and you sort of lose the will to live a little bit. But I think, again, you can do the same thing, and you can nearly say, well, this is always there. And if this is always there, it's just, yes, it's overly verbose, the bug will get fixed. Basically, this sort of collapses down. But basically, if it's always there, and we all sort of collectively understand what it's there for. The Puppet module tool actually provides a load of the tooling we need to do this. So if people aren't familiar, this is basically something that ships with Puppet that allows you to manage different modules in different ways. And one of the commands it has is generate. So actually, that's not valid. But Puppet module generate, basically name of module. You actually need a namespace there. That's going to basically give you a skeleton file system for doing your module. There is a default module skeleton that is inside the Puppet source code. And that's sort of where the problem comes, in that it's in the Puppet source code. I don't think it's changed for quite a while. And you basically get sort of manifest, spec, tests, module file, get ignore, readme. And that's it. It basically just creates those files. It creates some content in some of those files. But that's pretty much it. I think, actually, from my experience of sort of shipping a load of modules and helping other people sort of refactor their modules to be more reusable, we can be way more opinionated about this. And one of the things that I found is that although the default skeleton is inside the Puppet code base, if you have some code at this location that matches the format that is required, Puppet module tool will use that instead, which I think that's actually really, really useful, and I've seen hardly anyone using it. So I've shipped an example module skeleton that's very opinionated. It comes with a health warning at the top saying this is insanely opinionated. Other people can ship their own. We can have a conversation about what a generic structure looks like separate from modules, and I think we need to do that as a community. In my case, basically, it's a lot bigger. We'll talk about a bunch of these things, but it's got, as well as creating install config service params classes, so it's going to create classes based on the name you pass it. They're going to be named right. The relationships are all going to be there. It's also doing development dependency management with Bundler. So I want to be able to basically just create a module, and for the tests to pass on that module, even before I've written a line of code. In order to do that, basically, I need to install the dependencies for my tests, and we'll come to testing in a bit. It comes with loads of testing setup for RSpec Puppet Helper and RSpec Puppet. It comes with syntax checking and linting. It comes with configuration for Travis. It comes with integration testing, all of which will run out of the box for the generic module that, to start with, does nothing, but has all the skeleton in place. It adds module management with Maestro Blacksmith, which I found today is brilliant. Tools that allow for pushing automatically and managing modules on the Forge via the command line. And what this starts to do is basically allows us to start focusing on the interface to that module. We've talked about it in the abstract. We've talked about things, and we can reason about things separately. And I want people to focus on that repo and tell me where they disagree. And I don't think it's about having one skeleton that we all agree on. But I think Chad said something earlier. It's much more about there's probably 2 or 3 or 4 camps where we probably could agree on within those. And even then, if I'm using things across them, that's still a lot easier than at the moment where everyone has to recreate this wheel themselves. In particular, people are recreating this wheel from having lots of experience or having very little experience. I think in a lot of cases, with the same amount of experience, you reach this, like 1 or 2 or 3 conclusions. And we can get better at just simply shortcutting the need to do all that learning individually. We can minimize the points of entry. I don't want to need to know the entire implementation details of your sort of class hierarchy to know what to do. And I think basically if we've got conventions like the sort of the install params class service stuff, it's like, well, actually, how I interact with that is via the class. I don't do it directly to service. I don't do it directly to install. And back to that point about sometimes I actually just want to write Nginx configuration. Templates are good. Allowing me to pass in a template, basically to just override everything, is fine. Do that more than simply try and take every single option and turn it into a parameter. One of the things that stops people reusing modules as well is that it doesn't work on my machine. It doesn't work on my operating system. It doesn't work on the whatever version of my operating system I've done it. Because fundamentally, when I write my modules, I'm writing them I'm interested in other people using them, but I'm writing them for myself. And I'm probably not going to support operating systems that I don't have any interaction with because, hey, I can't be bothered. Sorry if someone. But we can have default parameters. We can set up things so logic is in one place. We can say, well, we can explicitly state that these are the things I support, and everything else will fail early, as we talked about earlier. And even if these are just stubbed out for other people to come along, then great. And we can start doing it. If people haven't seen it, it's worth having a look at the Armature 9 for how we can start making it much easier to share data inside modules via the sort of hero and module stuff. As an example of that, one of the modules I have on the Forge is for managing Erlang. Now, Erlang will run anywhere, but I actually really only cared about it running on Ubuntu machines I was managing. So basically, the whole first series of that just supported Ubuntu. Everything else, basically, it just said, yep, fail. The operating system loops were there, but basically everything else that wasn't Ubuntu failed. It just used basically the official Erlang PPA. That's never going to work on anything else. But the next series of this supported Ubuntu, Debian, Red Hat, SUSE. And the reason for that was open source. Some people came along and said, hey, you have an Erlang module. Do you want to support these other things? And I was like, yeah, sure. Pull requests. And that's actually now in use on the Puppet Labs RabbitMQ module. Because they needed to, it requires Erlang. And they were like, there's a module that supports Erlang. But they needed to support some operating systems I didn't. But actually, it wasn't a lot of code to fit in with what I had. They pretty much just had to modify the params. They had to basically put some extra logic in the params to catch the operating systems they cared about. They had to name the packages. There was some specific Yum stuff to do with the EPL repository on different versions of Red Hat. But actually, that all ends up looking the same for anything you do. It's not specific to this module. It's not specific to Erlang. It's not specific to anything else. And all of your modules end up looking the same, and that's good. But one thing is, open source is good. Shipping modules that work, do one thing well, and allowing people, basically providing the skeleton for people to modify them is good. But insist on tests, because fundamentally here we've introduced logic, and that's going to be brittle without having some verification of it. Especially when I don't have the capacity or will to necessarily test those modules in all the operating systems. I need computers to do that for me. Which brings us nicely on to sort of testing. Code should have tests. Puppet is code. Puppet should have tests. But sometimes it's sort of, well, why test a declarative language? And the answer is really, I think, sort of like, well, modules are increasingly containing logic. The operating system examples are a good idea. Depending on the operating system you're running on, the module does something different. That's a lot more complicated than the module just does this. Like, module installs this package and runs this service. Yeah, great. Module installs this package on this operating system, or this package on this operating system, or fails on this operating system, and on this, yes, the service is running on all of them, but basically it will have a different provider. That's much, it takes longer to say, it takes longer to reason about. And then that's where bugs come in, because basically there's now a lot more paths through my code, my Puppet code. We've got logic. We need to test for that. Modules increasingly take arguments, and sometimes lots of arguments, which then trigger some of that logic. Again, it's code. We need to test for this stuff, because otherwise people will pass in things that we don't expect, and they'll get unexpected behavior, and they'll blame our module, they'll stop using it, and they'll have their own version, and we haven't solved sharing. Modules also increasingly have interfaces with other modules. So that might be, you've got sort of defines passing through to different modules. You might have dependencies, for example, like the RabbitMQ to Erlang one. You need to test for those things as well, because it's great if your module works, but if it doesn't work in the context of actually doing what it's meant to do. So if the RabbitMQ module, if all the tests pass, but it doesn't install RabbitMQ in a running state because the Erlang module is broken, actually, that's my fault because it's my Erlang module. But who's going to blame me? No, they're all going to blame the people with the RabbitMQ module, who then are going to go, oh, we shouldn't have used Gareth's Erlang module. They're going to write their own. And again, we've got more modules. Modules are increasingly used in many Ruby and Puppet version combinations as well. And like, it's great to say, well, but I only run one version of Ruby, and I only run one version of Puppet. But hey, maybe I want to upgrade one day for one of those two things. And if modules are going to be shareable, they need to at least acknowledge where that, like, what versions they work in. And actually, testing on those things isn't too difficult. Mainly because the tools have got way better. And like, literally, even 6 to 12 months ago, the tools have got a lot better. There's actually a really good tool chain for Puppet module testing. I think the thing I like most about the module skeleton stuff is that it gives you all of this already set up and running. So now all you need to do is write the tests, not learn about all these tools. I'll fly through them, but they're all, like, taken together, they work really well. Puppet-lint is great. There is a Puppet style guide from Puppet Labs about how to, the sort of like, its style, its typographic style for writing modules, its layout. Following this makes module sharing easier because basically modules start to look the same stylistically. Puppet-lint is a checker against that style guide. You can opt out of some of the checks if you don't like them. You can basically install this and run something like this, where we get messages. So trailing white space found on line 1, variable not enclosed in braces on line 56. It's very specific. It says on this line something is wrong with the style according to the style guide. The problem with linting tools is that you might not agree. Tough. I guess I came more from a Python background originally in programming, and there is something massive to be said about everyone just doing the same thing irrespective of whether they agree or not. Ruby people probably freak the hell out about that, but they're wrong. Puppet syntax is actually something that a colleague, Dan Carley, put together at work, I think, which was basically, it will validate the Puppet and ERB syntax. And I think someone's got a pull request on it to make sure the hero data files you're shipping around are basically are valid YAML. There's a lot of little gotchas that you want to catch before you commit that code. And these start adding up. So we're checking the syntax of our Puppet stuff. We're checking our the style of our Puppet stuff. We also want to test the behavior of our Puppet code. So RSpec Puppet is unit testing for Puppet. It's about testing small components. It's about testing the catalog that comes out of our bits. So here is an example of basically just saying, well, if we're basically we're setting a parameter for equal enable, which is on this module, to true, and it should contain the class equal. If equal enable is false, it should not contain the class. And that's why testing of a seemingly declarative language is useful, because there's logic. I'm saying, well, basically, false means that's not there, true means it's there. I am much more confident in that code working. If someone changes something that is unrelated to this, and these tests pass, success. If they fail, it was related and no one noticed. There's also Puppet Labs spec helper, which basically makes this a bit easier to use. It provides a number of sort of fixtures. It provides a number of matches. It provides a number of sort of a skeleton around the sort of the raw RSpec Puppet tool to make getting started easier. But you can go too far fairly easily. Some of the matches within RSpec Puppet are sort of ensure that this package is installed or ensure this class is installed. Well, if it's always there, well, so your Puppet code says, package, ensure installed. And your test says, package, ensure installed. It's like you wrote the same thing in two different things. And yes, that gives you a bit more confidence. But if that's what you do and that's what you start doing, what you go is, what am I doing? I'm writing the same code twice in two different syntax, and you stop. There's a tiny bit of value in that, but ultimately that's the only thing you do, and you're doing it wrong. Test the interface, test the logic, test the things that you pass in, and that the reason you're passing something in changes. That might be you're passing something in. We mentioned sort of passing in a template. Well, am I now using that template? What does the output of the file look like? And you want all of these things together. And so Rake makes this really easy. Rake's basically sort of the build system that is generally used with sort of Ruby code that you can use to run these commands outside, basically outside their sort of separate context. So invariably, I have a task that I can run, bundle exact rake test, that will check the syntax. It will check I'm doing everything according to style guide, and it will run all my unit tests. And once I've got this way of being confident about the code I'm shipping, I can run it in continuous integration systems. And now I might be doing just private stuff, so I might be using Jenkins, or I might be using any other branded tool. The nice thing with Travis is that it's free for open source. So, and there's a couple other things which nice will come to. So all of my modules, and a load of the modules you see on the Forge, have got this little badge saying tests passing. And there's a conversation later with Ryan from Puppet Labs about well, how do we do sort of quality module discovery? One of my things is, if someone's written some tests, and I have a look at those tests, and they're not just duplicating the code, I am way more confident in the longevity and the utility of that module. That might just be me. That might be a developer sort of thing. I don't know. But I still think there's value in it. And seeing continuous integration tests running is great. Partly because we can run on the pull requests as well. So if someone sends me, says, hey, I've fixed a problem, or I've added new support for some new operating systems, their tests get run before I even know that they've sent that. And I get at the same time as I get told someone sent you some code to fix a problem or add some features, I get told whether they added tests and whether those tests passed, or whether some of the tests that were previously there failed. That's brilliant. The other thing that, again, Travis makes very easy, and you can do elsewhere, is this sort of matrix stuff. So RVM is basically a Ruby version manager. So here I'm testing on Ruby 1.8.7 and 1.9.3. And I'm testing with Puppet versions of basically the 2.7 series, 3.1 series, 3.2 series. And that's a matrix. So that's, for each of those versions, each of those Ruby implementations. So I'm not running my tests once. I'm running them 6 times here. Now, I'm probably only using one of those Ruby versions and one of those Puppet versions at a time, hopefully, probably. But anyone else can come along and say, do the tests pass on that version combination that they're using. That's really powerful. But up to there, you've only said, well, does it sort of, basically, does my module code sort of work? What you want to do is, you want to say, well, does it actually install RabbitMQ, and is RabbitMQ actually genuinely running on an actual machine when this code runs? So you get into integration testing. An RSpec system from Ken from Puppet Labs, if he's not around, is brilliant. I find this has basically been the easiest sort of starting point for just jumping into this. And I say it's integration testing against actually real systems. It's going to basically bring up a virtual machine and shut it down at the end. It's going to take all the modules, take all the dependencies. It's going to run manifests that you provide, and it's going to basically then assert things that you're asserting. So there's a bunch of so RSpec system is a sort of general system for sort of solving this, for anything, not just for Puppet. The RSpec system Puppet uses RSpec system to basically provide a load of hooks to make doing this with Puppet really easy. What it's doing under the hood is using Vagrant, and it's using basically the VirtualBox driver or the vSphere provider in the new Vagrant stuff to control virtual machines. So if you've got a VMware setup, you can just point your integration tests at that. It's going to occasionally fire machines up, and it's occasionally going to get rid of them. Or you can do that locally with VirtualBox. And you can test that actually, not just that the code sort of works, but you can test that actually the module installs on a real machine from scratch. So here we've got a class sample, and that's our entire manifest. That's the only thing that we're doing here. But basically, that could be any arbitrary Puppet code. That could be set up your entire web server class. And all we're seeing here actually is basically puppet-apply is a helper basically that's going to run Puppet. We can pass arguments to that for different options. And we're going to say the exit code should be 2. It should successfully run according to the detailed exit codes for Puppet. We can throw in testing that the app runs right important, so that if you run them a second time, well, straight afterwards, well, they shouldn't change anything. So just r.refresh, exit code should now be 0. So now we've run our Puppet code. It's installed something, and it worked. It didn't error. If it did, our tests will fail and tell us that it doesn't work. So if I break the Erlang module that is used in the RabbitMQ module, this will fail in a way that the unit tests for the module won't. And we can test the module. We can test anything. We can run arbitrary shell commands on there to test things. So here we can say basically, well, this is a test from my Erlang module. And well, if I'm going to install Erlang, I expect Erlang to be there. Or I expect ERL, the binary for that, basically to be in the right place. And I could do anything. I could run that. If it had a version command, I would run it, and it doesn't. And I can test that against multiple operating systems at the same time. Yes, that means multiple virtual machines, but hey, who cares? This sort of runs foul a little bit if you have a small laptop, but put as much RAM in any machine you can get. With the Vagrant provider stuff, you can now, in theory, point this at EC2. That doesn't work yet, but it wouldn't be difficult to do it. But you have just, here we've got, there's a bit of fluff in the config file, but here we've got sort of CentOS, we've got Fedora, we've got Debian. You can imagine there's Ubuntu and other ones down there below that. And with one command, we run all of our integration tests against all of these virtual machines at the same time and get told whether they pass everywhere. So, using standard library, testing your modules, actually by taking a really strong skeleton, taking a really strong sort of community-driven approach for how we structure modules, I think is a big part of sharing. But there's all sorts of things that I think would help sharing, and this is basically a rant for any Puppet Labs people in the room. I want to run my own forge. I said I work for the government. Sometimes I don't want to install arbitrary modules from a web server in America run by a company I have no commercial relationship with. Who'd have thunk it? Running air-gap networks, running things that are not connected to the internet. You can't take advantage of the dependency management stuff that's in the Forge. Pulp's interesting. You can start doing some basically sort of mirroring parts of the Forge with that. I think that's a good start. But ultimately, Puppet Labs manage the Forge. There's talk of basically them publishing the API and basically versioning that, and maybe that'll allow someone to write an open source implementation. But for a lot of people to really get behind shareable modules via the Forge, I think you need to be able to run your own first-class citizen version of it. Also, the Forge runs on HTTP. There's a whole host of other bits and pieces, but can someone just buy an SSL cert? Again, I'm downloading code that I'm going potentially from basically, at this point, the internet, who knows where, and I'm going to run it as root on all of my machines. Happy days. There's a lot, like I say, the SSL cert is part of it, but there's a whole bunch of security features that I would like to see integrated with that and integrated with basically being able to run my own. I want signed packages. I want all the things that come with sane package management, basically. I sort of made a joke of the sort of dependency management within Puppet. A lot of people don't use it. A lot of people aren't familiar with Librarian Puppet or RTK or a bunch of other tools that are there to do this. They work really well, but they're not, you don't see them written about on the documentation published by Puppet Labs, and that's the starting point for a lot of people. You have to listen to talks like this. You have to listen to half the other talks telling people about Librarian Puppet. You have to be on IRC. You have to be talking to the people who've been doing this for a while. That's not good enough. I think Puppet Labs need to basically, they need to bless basically whether it's a dependency management tool or a format, like the Puppet Lab, basically the sort of the Puppet file format that was sort of introduced with Librarian Puppet. Even if it's just basically they take that on, they standardize it, and they version it properly. People can build tools around it. They can build a tool around it. That's fine. But their documentation should start with using dependency management. I also want optional dependencies. I think when you start building a lot of modules that, like, if I start building a lot of modules that rely on my own modules, I start creating a closed ecosystem. And I think there's a risk that basically you end up with two ecosystems at the very least in terms of you've got the Puppet Labs ones that are basically, they decide it's too much faff to rely on other third-party modules like my Erlang one, which they're not doing at the moment. So credit to them for this. They are using third-party modules where they're good. But I think you end up with this risk of it being a closed ecosystem. And I think you can somewhat deal with this by, instead of making those dependencies really hard, you can make them optional in some cases. So there was mention earlier of taking two modules that both relied on different sudo modules, installing them, and boom, everything explodes. If those modules were basically both optional, you need a sudo module, but hey, and I've tested it with this sudo module. If I can say, well, yes, when I install this module, I can specify whether I want the optional dependencies or not. Maybe that's a way of doing it. That syntax obviously doesn't work. That's fake. Most of the syntax in the rest of the talk is fake. But maybe there's something there. I also want private classes. When it comes to like that sort of like the sort of init service packet install sort of params sort of structure, I don't want you ever to like basically instantiate the service class or the install class. It makes no sense in the context of the thing that I am providing to you. I want you to use my interface that I've designed at the top level for you to do that. At the moment, there's no way I can stop you doing that. That means that like the potential for you to misuse my module, for you to blame me for something that I can't control, in a way that basically means that you've done something that is wrong. It's like I want to be able to protect the implementation that I might want to change any time. And I think this is probably as simple as just like have the ability to specify private classes. I can say this is my side of things. This is my mess. I might change this at any time, but hey, the interface at the top level is the thing that you can instantiate. I think that's fairly straightforward. Again, it's adopting things from programming and bringing them into Puppet, which is a programming language whether we like it or not. Parameter naming is another area where like jumping between modules makes this difficult. Different people use the same words to mean different concepts. I think this is definitely a community thing where we can get together and we can solve this. Alessandro, who's unfortunately talking about the same topic in another room at the moment, has done some actually really good work about basically just documenting this. This isn't really about sort of whether you agree or not on the names that are chosen, but there's now a repository where people can fork, they can comment, we can have a conversation. And again, if we come to one conclusion that we're all happy, wow, that's amazing, that's not going to happen. If we come to a few camps where there are documents which you can then use, and hey, if there are documents we can use and we can agree on, maybe we can turn that into code. Because actually, yes, I want conventions for naming, but I want enforceable conventions in code that I can specify. I want interfaces in my Puppet code. I want to be able to do, and like this definitely doesn't work, and this is way more complicated than I'm going to make it out to be, and Puppet likes to just do it anyway. I want to be able to say, well, there's an interface. I want to be able to say it has these specific things. This is separate from any module. I then want to be able to implement it in my module. And I want that to be able to fail at different times. And it means we can, if I've got a module that's doing something, and someone else has got a module that's doing something, we can have a discussion not inside my module, not inside his module, but in something that we both agree on and share. And now, people can use either my module or his module, whichever they choose. And I think without actually interfaces as a first-class citizen, we'll never get to that. It won't work. And that's me. And I've got a minute left, which I might have time for questions. No one's dragging me off, so any questions? Oh, there's one back there. So the question was really about, so where do you draw the line in terms of too many dependencies? I think if you've got loads and loads and loads of dependencies on a specific module, that module itself is probably too big. It's probably reasoning about too many things. Modules want to be modular. They want to be the smallest thing that you can then tie together. When it comes to your entire repository, you're going to have lots of modules, but you want to minimize the dependencies between as many of them as you can do. So I think it's about making your modules as small as they can be and relying on the smallest number of things and making them work with other modules that do other different bits and pieces and having some of that dependency stuff in your project, your entire sort of manifest set, not within your specific module. Another question? One down here. Yeah. So the question is around sort of I guess programmatic ways of configuring things with very complex configuration. I think it varies a little bit. I think for me, I actually prefer the sort of a way of sort of say just passing a string, basically passing whether it's a template, passing something that I can then do. I can deal with that myself, and that might be a set of paths that then I can concatenate together. It might be something else. So I think where there's Nginx actually is very simple from a certain point of view. But I invariably do crazy things with it because the Nginx modules are ace. No one is ever going to sensibly build a module that's even remotely any good at doing that. And I know Nginx, and I just want to be able to configure that, to an extent, outside Puppet, and for Puppet to manage that for me. I think I don't like the sort of modules where there's a define with a massive number of parameters that's trying to be very opinionated. It's trying to say you don't need to know your tool that you know, you just need to know Puppet. And I think that's, the moment there's 50 parameters or something, that's not true. You need to know both. I'd prefer one parameter and go, I know that tool, and I will deal with that separately. And if that's actually very complicated, then write some code to generate that, or write the code to generate the Puppet code that does it, I think. I don't like really complex configuration moving into Puppet. I think it's an anti-pattern. Oh.
Do you have opinions about structures, params files, working with Hira calls inside of a params file?
So I'm a big fan of Hira, big fan of basically the